So we have a new YOLO member in the YOLO family, YOLO26. So this model here had just been released by Ultralytics, and we're going to see how we can set it up and also train it on our own custom dataset. So we're going to grab a dataset, train a new model, take a look at the inference results. Later on, we're going to cover way more on the channel, how we can use all the different tasks, how we can do tracking, how fast it is. We're going to do some benchmarking speeds and so on. And we're also going to cover the new details and key features with the YOLO26 model. So let's just jump straight into it. We're going to go into the Ultralytics documentation. So if you go to the website, we have the docs. So this model here, it's better performance, it's faster, higher accuracy on the benchmark datasets. Of course, we need to test it out on our own datasets and so on. Could be that some of the other models is still better, depending on the hardware and so on that you're running. So now we can see we have this introduction to YOLO26. Let's just click on this one here. So first of all, let's just take a look at the graph. Everything is available. You can use it in the exact same way as all the other models with Ultralytics. So it's very easy to get started with training and also running inference. And we're going to see how we can set up a full training run in just a few minutes and then take a look at the results after. But YOLO26, we can see if we just compare it with YOLO11, which is usually what I've been using, we can see we're getting better accuracy. The inference speed is roughly the same. We just get better accuracy. Where it also benefits is if you're using it on smaller edge devices or CPUs, it is significantly faster on CPUs compared to the YOLO11 model, while we're gaining this accuracy increase. So this is TensorRT floating point 16 on a T4, so this is an NVIDIA GPU. Doesn't really seem like we're getting any benefit here speed-wise, but if you're using CPUs or smaller devices, you will gain a latency decrease as well, and you will also get better accuracy. So we can see it's a pretty big gap here between these ones, especially if compared to the gaps between the other versions in our YOLO family. So 11, we have large, we also have the extra large up here, so we can see the extra large looks pretty good, 57.5, significantly higher than any of the other models mentioned in here. So it's very easy to go in and use. Let's just go in and take a look at one of the data sets. So we're going to open up a Google Colab notebook. So I'm just going to open this one up. This is very easy to get started with. Free GPU, we just have the pip install Ultralytics, drop in a few commands, and we have our full training pipeline for an update detection model up and running. So first of all, if you run into any problems, make sure that you have upgraded Ultralytics, pip install the newest version. So this is all we have to do. We can go inside the runtime. We can specify what type of hardware we want to run it on. I just want to run it on an A100. We have the T4 and so on in the free GPU here on Google Colab. So you can just use that. Now I'm just going to connect to the session and then also pip install Ultralytics. That's everything that we have to do. Now we just need to take care of our dataset. We have tons of videos covering how we can generate a dataset and so on. We just need it into the specific format that Ultralytics support. Then we have everything. We can trigger the training, run inference, evaluation, benchmarking, and then we can start use our model in our own application and projects and build the business logic around it. So we see it's already installed now. Everything is pre-installed. Let's go back into our documentation. So some of the things that I mentioned for the architecture is just the simplicity. So now it's a native end-to-end model. One of the cool things is that the reduction of non-maximum suppression. So every time a model does predictions, we get all different types of guesses of where are the objects. We will have tons of overlapping bounding boxes. We'll have thousands of bounding boxes, and then we need to figure out which bounding box fits best on the objects, and then we pretty much just minimize the number of bounding boxes, so we just end up with one bounding box around our objects. So this is a pretty heavy processing, like this is a post-processing step that's being done, but now it has been reduced significantly. This is also one of the reasons why it's faster on CPU now, because GPU, there's a lot of optimizations for non-maximum suppression and so on GPU, but on CPU, it's a very power-consuming operation. At least if you want to run real-time inference on edge devices and smaller hardware and also CPUs. So deployment efficiency is just an end-to-end model. We have introduction to MU-SGD, so this is just a new optimizer, task-specific optimizations. So it has done something for segmentation and also orange bounding boxes, where we have like a rotated bounding box instead of just this fixed rectangle or square around our objects. DFL removal into a non-maximum suppression free inference, This is pretty much just what I went over. There's some different losses, optimizations, algorithms, and so on that has been used. We get up to 43% faster GPU or CPU inference. So this is very significant. Instant segmentation enhancement, precision post-estimation, refined RNA bounding box decoding. So just in general, a huge step here in the improvement. There has also been some time since we got a new version in the YOLO family. All the tasks, all the modes, everything is supported. You can just grab them directly as in any other way with Ultralytics. So this is pretty much everything that we need. Let's now go inside our datasets, grab a dataset, and then run some training on that. With Ultralytics, we have datasets directly available out of the box, but you can also set up your own datasets. You can use auto annotation tools, all different tools. I have it here on my channel where I cover how we can create our own dataset. But let's just see how we can set up a full dataset pipeline in a few minutes. So let's take this update detection for brain tumor detection. Let's go down. This is the YAML file that we need to specify. So for example, this one, we just need to grab it. We're going to predict if it's negative or positive. We have our training path, we have our validation path. You can also have a test path and then where it's downloading the dataset from. If we just take a look at some examples, this is the images that is going in. So this is just all medical image scans where we want to predict if there is a tumor or not. So this tumor here could actually be an area where there could be a tumor, and then we're predicting if it's negative or positive. This is a pretty critical application. You can also use all the other datasets here in the exact same way. If you build your own dataset, you just need to format it in this way here, and also what I'm going to explain in a second. So what we need to do now is go back to our task. We can train. We can also have just our detection. So this is just standard detection that we're going to run. We can run a Python script or our CLI. Let's just run a Python script. It's just a few lines of code. Let's copy paste this one. There we go. What we're doing, we're importing YOLO from Ultralytics. Here, if you can build a new model from scratch, this will have random initialized weights, so then you need to pre-train the models first, but we want to run one of the pre-trained models Ultralytics has already done for us. So if you just specify .pt, it's going to use a pre-trained model, then we're only going to fine-tune it on our own custom dataset. Then we don't need tens of thousands or hundreds of thousands of images. We just need a few hundred to a few thousand, and we can have a very good model that we can use for our own applications and projects. You can also do it here if you want to transfer the weights, but let's just create an instance of our YOLO26 nano model. If you want to run segmentation, you need your dataset to support it, but you just specify it here, seg. It could also be pose, it could be OBB, and so on. This is pretty easy. Now we can just hit train. This is the dataset that we're going to specify. So we had the YAML file from the Ultralytics documentation. Copy pasted the wrong one. So if we go inside our datasets again, brain tumor, this is all we have to grab, and it will download it automatically. So once it downloads automatically, I'll go through the format. Let's just train for 100 epochs, and we also specify the image size. You can tune all the other different arguments that you can find inside the Ultralytics documentation. So if you go to train mode, scroll down here, this is all the different arguments that you can set. The data, epochs, this is what we are setting now. You can set patience, the batch size if you want to play around with that, depending on your hardware, how much RAM you have available, image size. If you want to save checkpoints while it's training the device, it's automatically going to detect most of these things. So just run with default parameters to start with in the exact same way as I'm doing. So let's just run it here. It's going to create an instance of our model. It's going to download the dataset automatically. While it's training, we can take a look at our dataset format, and then after compare the inference speed we're getting. So now we can see that the images has not been found, so it's going to download it to our computer. If you go inside the data or in the file explorer, we have our datasets, we have a brain tumor, we have our data YAML file. So this is the one that we saw from the documentation, the exact same one. Inside the images, we have all the images that we want. It's going to take a bit here to load, and then we will also have our labels. This is the specific YOLO Ultralytics format that we need for our labels, and then we're good to go. So now we can see that it has started the training. It's just going to run for 100 epochs. It might take on this GPU, it might take like 20 minutes or so, and then you actually have a computer vision model that you can use on your own. So we see it's pretty much done with first epoch here, so it will take pretty fast. You can go grab a coffee in the meantime while the model is training. So now we can see we opened up the labels. So we have a training folder and a validation folder. Let's just take a look at the validation folder. It's the exact same format, so let's open up this one. It has a corresponding image pair, so we need an annotation file and an image. So we have an annotation and image pair. First of all, here we have the index, we have the class that we want, so if it's either positive or negative, so this is a positive example, it will be 0 if it's a negative example. Then we have our normalized bounding box coordinates. So this is pretty much just the coordinates of our bounding box. You need to scale your values with respect to the image resolution that you use. And this is all you need to do to create your own datasets, but much more is covered on the Ultralytics documentation. You can just ask ChatGPT to convert your dataset into the Ultralytics format, and it will do everything for you. So this is just to understand the format. This might be different depending on the way you get your datasets and so on from, but most tools they export into the Ultralytics format as well. So we can see epoch 5, 6. I can already see that we get significantly faster training speed compared to the other models as well, like the YOLO11. Like this is just flying through the epochs, and this is usually the training setup that I'm using. So I'll just go grab a coffee while it's training here. We can take a look at the results, run some inference, see how fast inference speed that we're getting with this model here. So we can now see that the new YOLO26 model is done training, took around 20 minutes, and we end up with this mean errors position. It should be going up over time. Instead of going through it here, we can go inside our dataset explorer on the left side, go inside our run directory, we have our detect, and we have a training folder. So this is gonna be the weights. So we have a best.pt, we have all different learning curves, confusion matrix, results, and so on. So this is gonna be our training graphs. This is so easy to use. So we can see that our model, it has pretty much converged, both for a mean error position, we have our position, and we also have our recall curve. Our losses maybe still going down a bit, but we can see some of our class losses, bounding block losses, and so on are already converged. So we have a pretty good model now. We can go inside our confusion matrix and see if we're able to classify correct or not. So we see that we are missing some positives and negatives here and there. This might be necessary to use a larger model, but let's just go in and try to see if we can run some inference. You can see some validation predictions. So this is images that the model has not trained on. We need our models to be able to generalize to new images, situations, and so on that the model has never seen before. So if we want to run our prediction, I'll just load up our batch 1 prediction. But if we want to run inference now, we go inside our task. We want to run predict. It's just going to be a single command as well, and then we can loop through all our results and pretty much just output them. So let's try this. We're just going to create a new instance of our model. Now we can see we have some negative examples. We can see we detect some positive tumors here and there. Let's try to run it on our own image. So from Ultralytics, we can import YOLO. You can download the best weight, so just download it. It will download to your computer, and then you can use it in your own applications and projects. Then you just need to paste it in here. This is all you have to do, and you will be able to use your own custom model. So first of all, here in our model, let's go up and grab one of the images from our validation set. Let's just grab a random one. Let's take this one. We copy the path, throw it in here. This is all we have to do. We can also specify the confidence score in here if you want to increase it, decrease it, and so on. Right now, let's just have 0.20 maybe. You can hit save, show if you want to show them. Right now, we're just going to set save equal to true. This is all we have to do. We're going to create an instance of a model, run inference results, and then we're going to loop through it all. 12.5 milliseconds inference, and again we will get fast inference if we are running it on a video over and over again. But the cool thing that we can see with the YOLO26 model is the post-processing step. So in all the other YOLO versions, you pretty much see this 2.9 both in the pre-processing and also post-processing. And when we're talking about around 15 milliseconds, 15-20 milliseconds inference speed, then it makes a huge impact. If you have 1 or 2 additional milliseconds, that's pretty much like 10% faster already there just for single image. This is going to run faster if you run multiple images in a row. So it's only going to have even faster impact. It's going to be saved here to our detect predict. Let's close this folder. You can just run through as many images as you want. So now we're going to have our predict folder. This is going to be val1 image. There we go. This is the exact same image, but we are also looping through our results because the model, we're going to throw our image through it, we get our results out, and then we can iterate through our results. Could be that we have multiple detections in our image. This is how we can extract the bounding boxes. Mask, if you want to run key point with the post estimation models, you can get it in this way. This is for instance segmentation, the probabilities, so the confidence scores of our model if you're running RNA bounding boxes. Then on the results, we just call show and save directly, and it's going to show the image as we're doing here, but it also saves it to our results.jpg. This is how we can use the Ultralytics YOLO26 model in the exact same way as all the other ones. We just got a better model and also faster. We went through the details, the new architecture stuff, the key features of the YOLO26 model. Only going to create more. We're going to do some benchmarking with speed test on edge hardware. I have all different types of hardware devices that we're going to run it on. I even have cameras where we can run the models directly on the cameras as well with the Oak Inference. I've already created videos covering that for some of the earlier models, but let's see how fast we can get this new model to run. Hope you learned a ton. Definitely go and check out the new model. It's available. Make sure to use this over the other models now. Test it out on your own dataset and see how it performs. Hope you learned a ton. Hope to see you guys in one of the upcoming videos. Until then, happy learning.